In this lesson, we are going to convert small numbers between scientific and standard notation. So basically, instead of writing really big numbers in scientific notation, we're going to write really small numbers. So right here, in example number 1, 3 divided by 10 divided by 10 divided by 10. So another way of writing this expression, let me, I guess, write that. Try to start off on a good note. Expression is, normally we would do 3 times 10. Like if this is 3 times 10 times 10 times 10 times 10, we would write 3 times 10 to the third power. But instead, we're not multiplying by 10, we are dividing by 10. So we are going to go to the negative third power. So I'll give you another example. 4 divided by 3 divided by 3. So another way of writing the expression above is 4 times 3, not to the second power, because that would be times 3 times 3. It would be to the negative power of 2, or the power of negative 2, we'll say, negative squared. So in this one, another way of writing the expression above is 5. We're not going to write times 2 to the third power. We're going to write times 2 to the negative third power because we are dividing. Let's do it again. So another way of writing the expression above, 2 divided by 5 divided by 5 divided by 5 divided by 5, is going to be 2 times 5, not to the 1, 2, 3, 4th power, but to the negative 4th power because you're dividing by 5, not multiplying. Whoa, here's a lot of 6s. So another way of rewriting the expression, or of writing the expression above, is 1 times 6, 1, 2, 3, 4, 5, 6, 7, 8, not to the 8th power because we're not multiplying, to the negative 8th power because we're dividing. And lastly, the way that we can write this expression above is 2 times 7 to the 1, 2, 3, 4, 5, so the 5th power, but negative. Now let's try to identify scientific notation or not when we're talking about small numbers. Remember that scientific notation is going to be a number between 1 and 9 with a decimal. Some numbers. Remember, this decimal is kind of optional, and these numbers are optional because these could be 0 times 10 to a certain power. We'll put a number up here. So in this first one, we have a number 1 through 9, and then a decimal and some stuff. And then we have times 10, and then we have to the negative 4th power. So this is scientific notation. In this one, we have 13. Well, 13 is not a number between 1 and 9. Or is not a digit from 1 to 9, from 1 to 9, not between, but from 1 to 9. This is larger than 9. So this is not scientific. It's also not a normal number. It's neither of those two. So negative 3 times, well, 0.1, negative 3 and 1/10 times 10 to the negative 6th power. Okay, we have a negative number. That's fine. That's whatever. If you need to see it, you can put a positive or negative. It doesn't matter. Digit 1 through 9. Yep. And a decimal. Yep. Times 10. Yep. Okay. Not standard. Not a regular number. It is definitely scientific. This one right here. The problem is this 25. It needs to be a digit from 1 to 9. So this is not scientific, but it's not a regular number. It's neither. Okay, so this next one, we have the digit here, 1 to 9. We have a decimal and some other ones. It's times, but this isn't 10. This needs to be 10. So that's the problem. So it's not scientific, but it's not a regular number. It's just neither. And we have this last one, so negative, which is fine, and 1 through 9 points. Okay, this is scientific. Just so you know, there were no more examples, but a standard would be something like 4.75 or 0.00067. Just like any normal any normal sort of number is standard notation. Standard just means sort of like a regular notation. Okay, so let's do some examples here. So 1 and 2/10 times 10 to the negative fourth. So the number is no longer being multiplied, it's being divided. It's being divided by 10 4 times. So the decimal is going to move 4 spaces to the left. We're dividing by 10, so it goes to the left. So I'm going to write that here. This is where it was, and then we go 1, 2, 3, 4 spaces to the left. So our standard form is this number right here. And our scientific notation was originally given to us as 1.2 times 10 to the negative 4, the power. Let's try it again. So let's actually, So 5 and 4/10 times 10 to the negative third. So this number once again is being divided because it's a negative exponent. It's being divided by 10 3 times. Is that 3 right there? So the decimal will move 3 to the left. So 5 and 4/10, 3 to the left. 1, 2, 3. 1, 2, 3. 0, 0. So my standard form, standard notation, I guess it's just a notation. I don't know why. Maybe I'm so used to talking about algebra sometimes. This should say notation. Our standard notation is going to be 0.0054, which is 54 tenths, hundreds, thousandths, 10,000ths. So 54 10,000ths. Our original scientific notation was 5 and 4/10 times 10 to the negative third power. Let's do one more. So sometimes you'll see something like this. So we have negative 2. It's being once again divided by 10 5 times. So it's going to move 5 spaces to the left. So we have negative 2. Our decimal starts here. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Moved 5 spaces, or 5 place values. So our standard notation is 0.00002. So tenths, hundreds, thousandths, 10,000ths, 100,000. So 200 thousandths. Wow. And our scientific notation was the original negative 2 times 10 to the negative 5th power. Cool, not too bad, right? And lastly, let me actually try to do something here. Okay, I'm going to try to fit this all on the screen. Okay. There we go. So we have this number, and we're going to express this number in standard notation. We're going to change it. We're going to convert it to scientific. So we have 0.00045. So I need to place the decimal. Remember, I need a number from 1 to 9. And then I need a decimal and some stuff, and times 10 to the power or something. So I need to put the decimal. I can't put it here. I can't put it here. I can't put it here. I need to put it right here so that I can get that digit 1 through 9. So I need to put it right there. 4.5. I need to multiply by 10. I need to get here. So this is where the decimal, where I'm trying to put the decimal. To get back to where it was, I would need to move 1, 2, 3, 4 spaces to the left. To get back to, so I want it here, but if I put it here, to make it into the original number, I would need to move it left 4 times. So I need to put the decimal between the 4 and the 5. and I would need to move the decimal 4 spaces to the left. So it needs to be 4 spaces, but we need to move it to the left, so we need to divide by 10 4 times. So my standard notation was this number, and scientific would be 4 5/10 times 10 to the negative 4th power. Now, for example, 17. Wow, we've done a lot. Okay, so this is a negative, and okay, so we need to, once again, number 1 or digit 1 through 9 and a decimal times 10 to a power of something. So I need to put my decimal right there so that this can be 1 to 9. Now, I need to, if I was to put it there, I would need to multiply, or I would need to move it left. That's what I meant, not multiply. I would need to move it left 1, 2, 3, 4, 5, 6 times. I would need to move it. So if it was here, I would need to move it 6 times to the left. So I would need to divide it by 10 6 times, divided by 10. So the negative means I'm dividing. So I needed to put the decimal between the 3. Remember, you can describe it any way you want. Between the 5 and the 3. I would need to move the decimal 6 spaces. So maybe I'll write these out. 6 spaces to the left to get there. So my original number was negative 0.000000532. I don't feel like interpreting that. That's kind of the whole point of the scientific notation, is to express really small, really large numbers differently. So like this right here, I can say is 5 3200 times 10 to the negative 6th power. And that's it. Thank you.